Good afternoon, engineers. This class we will discuss about two important MATLAB library functions, max and min, for a given vector. How to find the max and minimum value and the index where the maximum or minimum occurs. These two things can be found out using a built-in function. We will briefly look into that. We will generalize and consider a complex function a equal to -4 plus j into 1, 3. No, 3 is real. Then -6 minus j into 5, then 5. This is a column vector. You can display a. It's a column vector. So there are 4 rows and only one column. So it is a column vector. Then we will find what is the maximum and minimum value of a. And where that value occurs, that also we can display. Val max, comma int max. These are the variable where the function will return max a. Val max is -6 minus 5. I. I or j, both are same. That means it will find the absolute value of a because a is a complex number, complex matrix, complex vector. It finds the absolute value of a. Absolute value is modulus. Real square plus imaginary square, square root. So it finds the absolute value of a, then it finds where the maximum occurs. In this case, first element -4 square is 4, 16 plus 1 square is 1, 17, root 17. Third is 3 square plus 0 square, 3 square, square root of 3 square is 3. Minus 6 square, that is 6 square, plus minus 5 square is 5 square, 6 square is 36, plus 25. Square root of that number. Then 5 square plus 0 square, square root of that. So it occurs in third index. Third index is -6 minus 5j. So absolute value of a is maximum in this. For first one, it is root of 25. 3. 6 square plus 3 square, 5 square, square root of that. Square root of 5 square is 5. So maximum value of all the 4 is third element, -6 minus 5j. We can just cross check absolute of a. So third is maximum, right? 7.8. So it displays in max is 3. Val max is the element where the maximum occurs. It displays the element -6 minus 5j. So for a complex matrix, maximum command represent the index. The index is where the maximum of the absolute value. Absolute value is more important. occurs. As I said, we are taking absolute value for verification purpose. Third element is 7.8102, or also lower than that. So third element is minus 6 minus 5g, that it displays, the max command displays. And index is third, so it displays 3. Here it displays 3. Then you will see the minimum also, like that. Val min, int min. Here where the absolute value is minimum, to display that element and that in the corresponding index. Val min is 3, index is 2. See, we already displayed the absolute value. It is the lowest one. This 3 is the lowest one. So what is the index? 1, 2. 2 is the index. 3 is the absolute value. So that corresponding element is, second element is 3. Because imaginary part is 0, absolute value is same as real part. Because real part square plus 0 square is real part square. Square root of that is real part, which is 3 here. So minimum, maximum for a complex matrix. For a real matrix, it won't find the absolute value, it will find the where the maximum value occurs. For example, b equal to 7, 9, minus 12, minus 4, 11. We will display b. 7, 9, it is a column vector. 7, 9, minus 12, minus 4, 11. So we will find the maximum and minimum value of vector b. Val, val max, index max of vector b. Here, absolute, it won't take the absolute value, it will take into account of the sign. For example, 7, 9, b equal to 7, 9, minus 12, minus 4, 11. Maximum value obviously is 11. Here, absolute value is not taken. So, minus 12 we don't consider, is not the winner. So, 11 is the maximum value. Because minus 12 is very small compared to 11. 11 is the winner. So, it is on index 5. Let us verify that. Maximum value is 11, index is 5. It is displayed. This is for a real vector. Then we will find the minimum, similarly minimum of a real vector. So we are displaying b here. Minimum is most negative, minus 12. So that is third element. Index should be 3. Value should be minus 12. So here we give minimum command. Sorry, I think I have not changed the variable name. I have made a mistake. Minimum it works properly, but by mistake I have given val max. I should have given val min. Val min. Because I am finding the minimum value, not maximum value. Val min. Val min in min. Val min is minimum of b minus 12. Index is 3. We have seen that, right? Minimum is minus 12. Nothing lower than that. Index is 1, 2, 3. So this is max and minimum commands of real vector. So we have just seen for complex vector. This is for real vector. Then we will see transpose of a matrix and conjugate transpose of a matrix. If it is a complex matrix, we can we can have conjugate transpose. If it is a real matrix, we will have only transpose. Conjugate transpose also will be same. There is no distinction. If it's a complex matrix, conjugate transpose will be different from transpose. Just we will look at it briefly. For example, at A equal to, it is a complex matrix. A equal to minus 4 plus J. Sorry. C equal to, we use already A and B for different problem. So C equal to 1, 1 minus 2 plus J into 4, 5 plus J into 6. This is the first row. Second row I am for second row I am putting a semicolon to distinguish. 7 minus J3. 7 minus J into 3. Sorry, 7 minus J. Then 3. Then 9 plus J. J6. Let us display C. C is a 2 by 3 matrix. C is a 2 by 3 matrix. We will find simply a transpose of C. C, this is called transpose of C. Just rows are made columns and columns are made rows. For example, this is the first column, second column, third column. This is the first row, second row. So, row will become column and column will become row. So, this is a 2 by 3 matrix. C is a 2 by 3 matrix. Transpose of C will become 3 by 2. This is a 3 by 2 matrix. First row, second row, third row. For example, 1, first element of first row, first column. Then this is second row, first column. This will become first row, second column. One will occupy the same position because row and columns are same. This is the first row, second column. This will become second row, first column. Second row, sorry. This is second row, first column. 7 is second row, first column. 7 minus 1J. First row, second column. This is conjugate transpose, sir. Sorry. It has it has changed rows into columns and also made a complex conjugate. This without dot. See, that's just this is conjugate transpose. First row, second column. Here it was second row, first column. 7 minus 1i or 1j. So if you complex conjugate it, it will become 7 plus j that occupies first row, second column. This is in second row, first column. That will become first row, second column. First row, this is first row, second column. And it has become complex conjugate. This is called conjugate transpose, not transpose. I made a mistake, sorry. It is conjugate transpose. Then this one, first row, second column, minus 2 plus 4i. Minus 2 plus 4i. First row, second column. This will become second row, first column. Minus 2 minus 4j. Second row, first column. Second row, first column is minus 2 minus 4. It has become complex conjugate and column become row. So it converts rows into column and vice versa. This is called conjugate transpose. There is another transpose without complex conjugating. Same, just converting columns into rows and vice versa without complex conjugating. So for that you should use a dot. See dot. This this is just transpose, not conjugate transpose. We will find out this. It will be similar to this, but no complex conjugation. See, for example, 1 plus real part is 0, so there is no change. Here, minus 2, this was conjugate transpose. Minus 2 minus 4i. This conjugate will not take place because this is just transpose. So it will become plus 4. Here it is 5 minus. Because of conjugation, it has become minus 6. Without becoming conjugation, it will be 5 plus 6. For example, we will see. What is C? The first row, third column is 5 plus 6. First row, third column. First row, third column, 5 plus 6. Third row, first column is should be 5 plus 6. Third row, first column, 5 plus 6. 6i. So it doesn't complex conjugate, converts rows into columns and vice versa. This is just transpose. Whereas previous one is conjugate transpose. Then some plot function we will see. Plot. How to plot variables. Let x be a variable. X equal to 0 to 99. Let us display x 0 to 99. Then y equal to x square. It is an array, so we use dot. Dot means every element will be squared. It has length 100. Each element will be squared. X square. Y equal to x square. Let us plot y comma x. We will see y comma x. This is x. Sorry, let us plot y first. This is y. This is x. So 100 square is 10,000. This is one D plot. Y is plotted against x axis. 0 square is 0, like that 1 square is 1, 2 square is 4, like that. This is a parabola. Y equal to x square is a parabola. So this is a plot of a parabola. Expand this. Here, this is a fig. We can save it as a fig file, dot fig file if you want. Save as parabola. We can give a name, parabola. Parabola dot fig. If you want, we can save it. I'm not going to save. If you want, you can save it. If you want, you can zoom and see any portion of this. You can zoom it. Zoom. The plus function will zoom. Any portion of this, you can zoom. You can zoom it. In the small portion, we can zoom. For example, 48 to 58, you can zoom. This is we can zoom this. We can save it, and we can take a different color. Plot Y. We can have a red color, for example, red. We put it in quote or means red. So same thing, instead of blue, it comes red. Like that, green, different colors, black, different colors we can choose. I I will use another plot function. M equals to sine. This you please keep in mind how to generate a sine. I have already explained earlier on occasion. So this I am repeating. One of the exercise problem will be using this technique to generate a sine or cosine wave. Sine 2 into pi, 2 pi into I am generating 20 hertz of sine wave. 20 divided by 1000, 0 to 10,000. This is a sine wave of 10,001 samples. Because 0 to 10,000 means 10,001 samples. Sinusoidal frequency is 20 hertz, sampling frequency is 1000. This is a vector of 10,001 by 1. It is a vector. It is a row vector. Let us find the size of A, size of M. It is a row vector. One row, 10,001 column. If you want column vector, same thing we can give just dot. This is real, so it doesn't matter. But anyhow, we will give. This will change rows into columns and vice versa. Now we will find the size of M. Instead of 1 by 10,001, it will be 10,001 by 1. 10,001 by 1. This is a column vector. Then n equal to cos 2 into pi into 20 plus this 20 hertz divided by 1000 into 0 to 10,000. I put dot and this makes, instead of row vector, it makes a column vector. Generally, we follow the column vector. Default is a column vector. Any variable will be represented as a column vector. That is our convention, not row vector. So row vector becomes a column vector. So it will be 10,001 by 1. 10,001 rows and 1 column. This is a column vector. So it is displayed. So we will find size of n. 10,001 by n. We will plot m. So it is plotting a sine wave. Here we can't make out, but if you zoom, we can find out it is a sine wave. We can zoom it. See, it is a sine wave. We zoomed it. This is a sine wave. Default is blue color. It is a sine wave. We will plot cos wave over the over the sine wave plot. We will plot both. So for that we use hold on command. Hold on. So first it plotted m, then it will plot n in the same figure. Hold on, plot n. It will plot in the same figure. We will give a different color. Otherwise there will be a confusion. Sine wave was plotted with the blue. Cos wave will plot with the red. Hold on means it will plot in the same figure. We will see the plot now. We will zoom it and see. The plus symbol, it will zoom. I click on plus. Any area near 10,000, I can zoom. Here this is 10,000. Close to that, I can zoom any area, any portion of the figure. I see. Red was cos, blue was sine. They are not in the same phase. Peak is not occurring the same time actually. Because sine and cosine are shifted by pi by 2, right? Sine 0 is 0, cos 0 is 1. So they are shifted. So red is cosine wave, blue is sine wave. If you want further, you can zoom. If you want, you can zoom further. If you want, you can save this into some file. Save as some name you can give. Sine cosine. Sine cosine. I give a name sine cosine. Dot fig. Sine cosine dot fig. You can give. I didn't save, but you can save it. If you click on save, it will save. If you want to open a fig file, open any fig file. If you want to open, you can open it. So we have just seen how to plot a variable, how to plot variables using plot command. We have seen max and min. I'll give some. So with this MATLAB commands ends. Important MATLAB commands I have explained. Now I will give some simulation assignments. You may do the homework, and volunteers may help in making understand the engineers. Assignment homework. One. First problem is generate a sine wave of frequency 50 hertz, sampling frequency equal to 1000 hertz. Starting from sample n equal to 0 to 99,999. There are 1 lakh samples. N equal to 0 to 99,999 samples. Generate a sine wave, add plus 0.2 volt DC. Let me generate the sine wave, add 0.2 to the vector. This is vector. This will be a row vector. So use dot this to convert row vector to column vector. So this will become 1 lakh by 1 column vector of sinusoidal frequency of 50 hertz. Sampling frequency 1000 hertz. You have generated, add 0.2 volt DC. That means each element you have to add 0.2. So you add it, plot, call this. This is first. Second, add zero point 0.2 volts. DC. Third, plot the sum. in green color. You can use help plot command. Help plot. You can type in command window help plot. It will give. It will explain help and the command if you give. In this case, it is plot command. Help command window. Help plot if you give. You have to give G for green within quote. Single quote. This is the first assignment. Second assignment, similar way. Generate sine wave 20 hertz sampling 1000 hertz similar to previous problem. Sample n equal to 0 to 99,999. It is totally 1 lakh samples. Use a function sine gen dot m. In this file sine gen dot m, it will have sine gen dot m file. It has input parameter. Input parameter, you have to write a function. Basically, you have to write a function. It tells how to write a function. Input parameter is sine frequency, input frequency, input frequency, input frequency, sampling frequency, sample frequency, start sample, end sample. These are the four parameters you have to pass. It will be parameter will be passed in this bracket, not square bracket. Okay. Then this is the input. There are four parameters: input frequency, sampling frequency, start sample, end sample. Then another file B cosine cosine gen dot m file. Similar to this input parameter, input frequency, sample frequency, start sample, end sample. Start sample will be n equals 0. End sample is n equal to 99,999. Input frequency is 20 hertz. Sorry. Yeah, 20 hertz. Sampling frequency is 1000 hertz. This is second file, second dot m file. One main function will be there that will call this function sin gen dot m cosine gen dot m. Then in the same main file, product function, product wave. So say sin gen dot m returns sine samples. It returns sine samples. It returns cosine gen dot m returns cosine samples. It returns. I put in square brackets because it is returning. The main function product sample, product sample, product sample equal to sine sample dot star cosine sample. So this will have 1 lakh by 1 multiply sample by sample multiplication. It is not a matrix or vector multiplication. Sample by sample. Dot star. Please remember I have taught about that in your classes. Each sample, sine sample 1 will be multiplied by cosine sample 1. Sine sample 2 will be multiplied by cosine sample 2, etc. Sine sample 99,999 will be multiplied by cosine sample and 99,999. Totally 1 lakh product sample will be there. So now you know how to write a function. Main function, this is a main file, calls sine generation, cost cosine generation. In the main file, you process this sine sample equal product sample equal to sine sample multiplied by cosine sample. Then you plot sine sample. Hold on. Or you, I don't want to give this details. Plot sine sample, cosine sample, sine sample in blue, cosine sample in red, product sample in green. Use hold on command. You have to do that. You have to plot it. So this will give you an exercise problem for creating a function, how to use it and how to plot it. Next, last assignment. Generate 1 lakh by 1 Gaussian or normal. Zero mean unit variance. Samples. Find the minimum value. Minimum and maximum value of the vector x equal to this is Gaussian random vector. Randian use random. This is a hint. Randian command. Find the maximum and minimum value of the x vector. Then find val max minus val min. Maximum minus minimum value. You find out. Then divide this by 40. Val max minus val min by 40. Divide. You are dividing. Suppose val max is example. Val max you got 4.21. Val min minus 4.12. Difference is 4.21 minus 4.12. So you find out this. You divide it by 40. Then x is a vector, right? Random generator, 1 lakh samples you have generated. So find val max minus val min divided by 40. Count number of x occurring between number of x between val min to let us call this w. Val max minus val min divided by 40 is w. Val min to val min plus w. Then val min plus w to val min plus 2w, etc. Val max. In each width, val min to val max, sorry, val min to val min plus w, val min plus w to val min plus 2w, each one count number of x, count the number of x. Suppose x is between these three, first element you find out x1. X1 is between these ranges, between these two limits. You make the counter for this 1. The next 10th element is again within this. You increment 1. 1 plus 1 will become 2. So the number of x within each range you will count. That is called frequency. I will call it as frequency. So this is frequency 1. Second is frequency 2, etc. Plot frequency. Frequency is a vector. First element is this whatever number of x occurring between these two limits. Second element is second element of frequency is whatever occurring val min plus w2 val min plus 2w, etc. Last element is val max, that is ending with val max. Here the minimum ending will be val max minus w, val max minus w to val max, it will end. So plot frequency. This is an exercise problem. So you are generating a Gaussian random vector of 1 lakh samples. Find the maximum value and minimum value, divide it into equally by 40. Find the width of find the width, which is val max minus val min divided by 40. That is the width. Within each width, say val min to val min plus w, val min plus w to val min plus 2w, etc. How many x's are there? Suppose val min, so for example, minus val min to minus 4.12, just to give you an example, minus 4.1 to minus 3.9. Within this, number of x occurs is 60. So frequency of 1 is 60. Frequency 1. 1 is 60. Like that. Each width, how many times x occurs, that you will put into the, you should basically use either a if else or switch function. Use if else or switch switch function. Plot the frequency versus the bin 1, 2, 3, etc. In each bin, how much frequency it has occurred. This will use if or switch function. Switch or if else. One of these you can use. You can plot. This will give a good exercise. So you have plot. You use how to use a function, how to use find the minimum or maximum. Then how to use if or switch functions, switch commands. So these are the exercise problems. So with this, I stop this class. You may do the exercise problem. You may take help from volunteers.